viewers, this lecture is about the catalyst that works in the chemical kinetics. Before starting catalyst, let me tell you that what is chemical kinetics. Basically, chemical kinetics deal with a specific area of chemistry that deals with the rate of reaction. The point to be noted here is that chemical kinetics is way different than stoichiometry, in which stoichiometry deals with the theoretical assumption. Just suppose that we do have as a variable S plus O that produces 2SO, and then in stoichiometry we do balance it, here the 2 and here the 2, and this is how stoichiometry works. But in the chemical kinetics we do work on how this 2 reacts with this 2 and it produces this 2. Basically, it is based on the practical and experimented assumption, but the stoichiometry deals with the theoretical part. Let's move on to our real topic, that is catalyst. What is basically catalyst? Catalyst is something that performs a specific action in a reaction. Whether it can increase the reaction, whether it can decrease the reaction. But it doesn't dissolve in the reaction, it doesn't act as a reactant or as a product. But it do rate the reaction to be increased or decreased. The catalyst is basically of two types. Before moving to the types of the catalyst, let me show you how a catalyst works. Just suppose that we do have a reactant A plus another reactant B that reacts and become a product, that is AB. This is a general thing or a general process that happens, but the thing is that this A reacts to B. That's general, but here we want to speed up the process. We want A and B to be constantly or speed uply react to each other. So what we're gonna do, we're gonna add here a catalyst C. What will generally happen? This catalyst will work as C. That means that it will end up as a reactant, but when this reaction will be end up, A and B will be combinedly come out and C will be separately given up as a solid or as a liquid or as any of the substance, whether it can be as a water vapors. But this C that was then catalyst will be shown differently. A common example of that can be, let me just first remove it. Okay. Just suppose that this is a container. Okay, it's not visible. This is a bit visible. Just suppose that this is a container. Okay, now there is water inside this container. Just suppose that this is a water. Now we want to boil up a potato in that. Just suppose that we want this potato to be mashed up in 25 minutes. But the normal reaction took 1 hour to be done. Now, in that condition, what we will do? We will simply add a iron powder in it. Now what will iron powder do? Iron powder will react it. It won't be dissolved, but it will speed up the way that the water boils. When the water boils fast, the potato can be mashed up more quickly and more fluently. So we're going to reach the target of the 25 minutes very easily. This is the basically work of a catalyst. Now let's move on to a negative catalyst or a positive catalyst. Basically, this positive catalyst increases, you can learn it also with the symbol positive and negative. A negative catalyst increases the reaction, whether here a inhibitor or retarding catalyst, or it is also known as negative catalyst, that decreases the rate of reaction. Here are some common examples. Iron powder, as I have also added it to mash up the potato, but that's a general type or general example of a positive catalyst. After that, V2O5, vanadium pentaoxide. That's also a kind of a positive catalyst. After that, MnO2. That's also a type of a catalyst. These are the common catalysts that are termed as a positive catalyst. After that, inhibitors, alcohol, not much alcohol, but 2% of the ethyl alcohol work to oxidize the chloroform. After that, glycerine. Glycerine works as a negative or inhibitor when the decomposition of H2O2 happens. It works to slow down the reaction while the decomposition. After that, we do have so many types of that too. Like we do have two types of the processes of a catalyst, in which one is heterogeneous and second one is homogeneous. And in the homogeneous, there are also two categories or two classes. First one is called a acid and basis catalysis, and second one is called autocatalysis. But we're gonna cover these topics in upcoming videos. Till then, bye bye.